Question number 46. 1 mole of alkene P on reductive ozonolysis produces 2 mole of compound H and 2 mole of compound L. So we have H and we have the compound L. So if we talk about the total number of carbon atoms that should be present in alkene P, we have 2 moles of H and we have 2 moles of L. So there are a total of 8 carbons present in the substrate. So if we look at the options now, we can eliminate option 1 as it has 10 carbon atoms. If you look at the second option now, the second option has 8 carbon atoms. If you look at the third option, it also has 8 carbon atoms. And the fourth option also has 8 carbon atoms. So 1 is eliminated. Now students, we have to check for the formation of the compounds H and L. So students, we know that upon ozonolysis, we just have to break the double bond and replace it by double bond O. So if we try and break the bonds given in the second structure, so we'll have acetaldehyde as one of the products. This is also incorrect, as the examiner has told us that there is only formation of formaldehyde and not acetaldehyde. So if you look at the third option now, the third option will produce the substances which are given in the question. So it is going to produce 2 moles of the trione, whereas it is also going to form 2 moles of formaldehyde, which are present at these positions. And now if we look at the option given in 4, we can see that this is going to be cleaved like this. And it is going to give glyoxal as one of the products. So this is also not a correct option. So students, we have to mark option 3 as the correct answer to this question. Let us look at the next question now. Question number 47. Consider the following reaction. So we have a cyclic structure which is allowed to undergo hydrolysis. And the examiner is interested in the major product A, which is formed. So let us try and figure out the compound which is formed. So in the first step, the H plus present will cause protonation of the alkene. So on reaction of this alkene with H plus, we are going to get this structure. Now we'll have ring expansion in this case. So we can break any of this bond and shift it. So we'll have the formation of a 6-membered structure. With a carbocation at this position. Now this carbocation is able to undergo further ring expansion, which will lead to the generation of this carbocation. Now students, this carbocation is stable and it will not undergo further rearrangement. The H2O will attack this position and it is going to lead to the formation of a tertiary alcohol. Okay. So this is our product A. Now if you look at the options, statement 1, it says compound A is a secondary alcohol. It is incorrect, students. It is not a secondary alcohol. It is a tertiary alcohol. Let us look at statement 2 now. Compound A on reaction with concentrated H2SO4 followed by reductive ozonolysis give cyclodecane 1,6 dione. So this substance A, when it is subjected to concentrated H2SO4, it is going to cause dehydration. It is going to form an alkene. And now it is allowed to undergo reductive ozonolysis with O3Zn. So which will just break the double bond and lead to the addition of 2 double bond O, where the alkene had been initially present. So if you look at the name of this compound, it is indeed cyclodecane 1,6 dione. So statement 2 is correct. If you look at statement 3 now, product A formed is named cyclopentyl pentanol. It is incorrect, students. It is not named as cyclopentyl pentanol. If you look at statement 4 now, compound A is also formed by the reaction of this structure with B2H6THF and H2O2OH-. So students, this complete reagent belongs to hydroboration deboration and it is going to give us a secondary alcohol. Okay, and not the alcohol which is formed as compound A in the question. So students, we have to select the correct statement for this question and we have to mark option 2 as the answer to this question. Let us look at question number 48 now. It is given to us that compound P has formula this and it exists in many conformer forms. We have to select the incorrect statement. So in the first option, the examiner tells us that if X is equal to Y equal to CH3, then the antiform is more stable. Students, this statement is correct. If we draw the conformers of the species given in option 1, we can see that we are going to obtain this structure, and out of all the conformers possible for this structure, this is the most stable one. If you look at the statement 2 now, if y is equal to x is equal to h, then the staggered form is more stable. In this case, students, all the groups are similar and there is no distinction between the Gauche form or the staggered form or the anti-form, and this is more stable as compared to the totally eclipsed structure. So students, this statement is also correct. If you look at the third statement now, if x is equal to OH and y equal to F, then the anti-form is more stable. This statement is incorrect, students, because in this case we can have hydrogen bonding. So if we put them in the Gauche position, so in the Gauche position, the lone pairs over fluorine and the hydrogen can interact, forming a hydrogen bond. So this is the more stable structure than the anti-structure. So statement 3 is incorrect. If you look at statement 4 now, if x equal to y equal to CH3, is talking about the species which was present in 1 itself. And if we compare it to the totally eclipsed form, the totally eclipsed form is going to have the maximum energy because of the greater repulsion between the two CH3 groups which are present. So statement 4 is also correct. For this question, we have to select the incorrect statement and we have to mark option 3 as the correct answer to this question. Let us look at question number 49 now. Question number 49, it says, one of the method of preparation of N2 is heating of dichromate salt of ammonium ion. So we have ammonium dichromate changing into N2, Cr2O3 and H2. So it is told to us that in the above conversion, the equivalent weight of ammonium dichromate is. So in the above conversion, we have to find out the equivalent weight of ammonium dichromate if the molar mass of ammonium dichromate is equal to M. So students, we can find out the N factor by using any of the species undergoing oxidation or reduction. So in the ammonium ion, the nitrogen is present in a state of -3. Whereas if you look at N2, it is present in a state of 0. So there are a total of 2 nitrogen atoms and each of these nitrogen atom is losing 3 electrons each. So students, we can say that the N factor of this species is equal to 6 and the equivalent weight will be equal to the molar mass divided by 6, which is given in the first option. So students, we have to mark option 1 as the correct answer to question number 49. Let us look at the next question now. Question 50. A 1 gram mixture of sodium carbonate, NaOH and inert soluble impurity is dissolved in water to make a 20 ml solution. The solution required 30 ml of 0.5 molar HCl to phenolphthalein endpoint and further 10 ml of same sample of HCl to reach the methyl orange endpoint. So we have to comment on the percentage of the inert matter in the mixture. So students, let us assume that the millimoles of Na2CO3 be equal to X and the millimole of NaOH be equal to Y. So for the condition of neutralization, we have the MEQ of acid equal to base. Now, in presence of phenolphthalein, let's call it as PLN for short form, only half of the gram equivalents of Na2CO3 are neutralized. So we have X, and if you talk about NaOH, it has no problem getting neutralized in presence of phenolphthalein. So X plus Y shall be the total MEQ of the base. This should be equal to the MEQ of the acid, which is equal to 30 into 0.5. If you look at the second titration now, which was done using methyl orange, let's use MO for that. So in presence of methyl orange, the remaining half gram equivalents or milli equivalents of Na2CO3 which were present will get neutralized. So we have the X MEQs which were left unneutralized. So they require 10 ml of the 0.5 ml HCl. So we have 10 into 0.5. So on solving the second equation, we have X is equal to 5. And if we put the value of X in the first expression, we have the value of Y equal to 10. So in the 1 gram mixture, we have 5 millimoles of Na2CO3 and we have 10 millimoles of NaOH. So we can probably figure out the mass. So the mass of NaOH will be equal to 400 milligram, and the mass of Na2CO3, it shall be equal to 106 into 5, which is equal to 530 milligram. So students, we have a total of 930 milligram of base in 1000 milligram sample, which means that the impurity is equal to 70 milligram. And if we talk about the percentage, so we have 70 upon 1000 into 100. So on simplification, this gives us a number equal to 7%. So students, we have to mark option 2 as the correct answer to this question. Let us look at the next question now.